Hello students, today we will look at the second presentation on places to move. We have earlier seen railway stations and we saw how tremendously the stations have changed today. They are not just simply railway stations but they have become multimodal hubs connecting trains, road transportation and even airports close to next to them or close to them, as in the case of the works we saw of Santiago Calatrava. The next places to move is the one building that really excites us, and it become a very important symbol in cities across the globe, and those are airports. Airports are exciting even today for so many of us. Seeing flights take off and land in airports is an exciting thing to watch. This is the poetry of flight. Airports also have undergone tremendous change, from being transit sheds, as you see in this picture here of the Atlanta Municipal Airport in 1961, just standalone airports. They have now become civic mega hubs and gateways, civic landmarks and engines for global growth. Airports are today a very complex and ambitious buildings embodying technology, commerce, culture and even our national identity. So airports shape the first and last impression of a country. Railway stations also do that, but many times railway stations or these today multimodal hubs are confined to particular cities, and they do connect country to country also, but it is the airports which are more the national image that we see while entering a nation or departing from a nation. They function beyond transit. They are associated with, for example, tourism, of course, business, diplomacy, and governments invest heavily in airports because they project our national identity. So airports are shifting and now they are becoming mega hubs. From regional airports, there are global hubs. Tens of millions of people use airports every year, and there is a hub and spoke system that concentrates traffic in mega airports. So for example, if when you talk of the hub and spoke system, what is the hub and spoke system? There is a central hub airport, like for example here in the United States in Atlanta, that is a hub airport to which many spoke airports like Baltimore, like Memphis etc. are connected. Passengers from the spokes converge at the hubs and they're transferred to other flights. Many regional flights feed into this single large hub and creates a very high passenger volumes there. Hub can support frequent long haul flights. They are massive terminals with very advanced logistics. Therefore, they've evolved into mega airports. In India, for example, when we talk of Delhi, Mumbai and other mega cosmopolitan cities, big cities, there we are talking of hub airports, and smaller cities are the spoke airports. And there is a similarity now between global air network and global railway density. Now there is a very interesting comparison. When you look at this maps here, you see that airport, the air traffic chart indicates confinement, or rather the airports are confined to these specific spaces globally, and very interestingly you find similar areas of concentration of railway multimodal hubs globally. So there is a shared underlying driver between airport hubs and railway station hubs. One is economic activity. Both are concentrated in places that are economically developed or they are fast developing economies like India and China, and there are industrialized regions. And the population density is a factor where there is high density population that support frequent train and frequent flights, that the demand is generated to make these large networks viable. Urbanization is a factor. Dense cluster of major cities create this intense transport corridors for both these hubs. In many cases, airports and railway stations are part of the same multimodal system. For example, in the Heathrow Airport, not only is it an airport, but it also has underground railways that are connected or that are linked with the airport, and similarly it's true for the Frankfurt Airport. This shows the growth in air traffic over the years. From about 310 million in 1970, it grew little over 5 times within 30 years to 1.7 billion, And by 2019, pre-COVID, 4.5 billion people were traveling by air annually. And architecture now had to respond to a very large and very much more complex terminals. As you see in 2024, about 4.9 billion people have traveled globally through air. So what are the key changes if we just look at that once more together? One is from functional sheds, they are becoming architectural landmarks. From very cluttered layouts, there is very clean modular planning. From very dark interiors to very daylight filled transparent spaces. And from small regional terminals, they are becoming global mega hubs. And instead of a lot of hidden backstage kiosks, there is visible intuitive passenger flows that is happening. And from energy hungry buildings, we are having sustainable energy efficient buildings today. The other changes are in security protocols, particularly after the events of 9/11. Passenger comfort has increased tremendously. Commercialization has grown tremendously in airports with duty-free shops and retail. Technology like automation, biometrics have really become very dominant in modern airport hubs. There is sustainability and carbon neutral goals associated with airports. So they have become architectural icons today. In the early 20th century, like I said, they were more like utilitarian hangars and sheds. By mid 20th century, we had the first machines for flying. They had started becoming engineering marvels. Like by late 20th century, airport had become architectural statements, but today they are a hybrid of infrastructure and civic architecture. They are a multi-modal hubs globally. So if you look at airport as civic architecture, they shape a city or nation's identity like railway stations used to do in the 19th century. They act as gateways to the nations and serve as symbols of our technological progress and our global connectivity. Contemporary airports have grown into these urban hubs on a monumental scale. They are very large, very ambitious buildings with vast interiors, soaring roofs, dramatic structures. What railway stations had done, today airports are doing. This is the Beijing T3 terminal, and these are designed to inspire this awe and civic pride in the way they are designed and constructed. They are also an architect stage today. Star architects are associated with the airport projects. They are very high profile commissions with world famous architects, and their signature projects, just like museums are today, that define an architect's career and a nation's image. For example, tremendously amazing airports like the Incheon T2 terminal in South Korea or the Istanbul terminal by Grimshaw and Nicholas Grimshaw and other architects. So design here is seen as strategic. It improves efficiency, the overall passenger experience, and also the nation's branding. So no longer just an engineered space, they are architectural showcases. For example, in Incheon, and the growth that is happening in Incheon Airport in Korea, they first had the original terminal, the Incheon T1, which was built in 2000 by Fentress. And now the new one that I have shown you in the previous picture also, this is the new one, the T2 terminal by Herem and other architects. They have built it in 2018. Then there are other big terminals like the Heathrow T5 and the Barajas Airport, which we look at in detail, both by Richard Rogers. So we look at high tech and beyond in these buildings. High tech architecture is the natural home of airports, the modern airports. Exposed structures, long spans, modular grids are all associated with high tech architecture. Of course, the original very raw spaces like the Lloyds of London with exposed surfaces on the outside that I taught you earlier, it has now become an experience centered design. There is a huge amount of technology that goes into making an airport, and high tech architecture really suits this brand of building or this building typology. Look at these airports. This is the Stansted Airport, the Barajas Airport, and both of them we will be talking about in detail. Both of them, for example, have this branching tree-like structural columns that support the roof and create this lightweight interior space. airports are urban systems I was telling you about. In fact, the new word that is being used for them is called aerotropolis or airport city. This was coined by John Casarada. Aerotropolis is a city-like urban form where airport functions as a central hub around which there are business facilities and hotels, etc. Like here is the Chek-Lap-Kok Airport in Hong Kong by Norman Foster, which brought about a tremendous evolution or revolution in airport design, the modern airport design. It was a massive terminal built on a man-made island, but today it also has a hotel here, and a convention center here. So it is an aerotropolis. Airports therefore not just terminals, but they are like mini cities with hotels, convention centers, transport nodes, and the equivalent, like I said, of railway multimodal hubs. They are both transport driven ecosystems, and a lot of places like Dubai, Incheon, Singapore, Changi Airport, they are all clubbed under this airport city category. And urban planning meets architecture in these airport cities. For example, here in Incheon also you find the hotel here, so a lot of other facilities which are surrounding the Incheon airport in South Korea. Now, there is this timeline of landmark airports in which Stansted plays a very important role, and we will see why. It is a prototype of the modern contemporary airport. Then we have Kansai, which was an engineering marvel, also built on a man-made island in 1994 by Renzo Piano. Chek-Lap-Kok, also on a man-made island, a mega hub by Norman Foster 1998. Barajas, we will see in detail, is a civic, it is termed as civic humanism, and we will see why. And Beijing T3, which is a global spectacle. Now in the 1970s, 80s, a surge in global air travel and big airports across the world became very crowded and chaotic, but now very busy terminals are much more user friendly with these high tech features and renovations done in them. If we look at a historic context, we need to go back to Stansted Airport in 1991. London needed a new airport because of increasing capacity. The previous airports like Heathrow and Gatwick were very cluttered and confusing. The aim was to have a very clear, legible, passenger-centered airport. And this particular airport by Norman Foster challenged the very accepted rules of terminal design and went back to the roots of modern air travel. And so it is said that Stansted Foster transformed the terminal into a kind of cathedral of travel. This was a quote given in the New York Times. What really happened? You see, the earliest airports were very simple. There was a road on one side, and then the flights took off on the other side of the terminal. This small sketch indicates that there is the land side where you come to the airport or you depart from the airport, and then there is the air side. So the progression from the land side to the air side was very simple. You walk from the car through the terminal and out onto the plane, which was always in view. But over time it became very crowded and chaotic. What Norman Foster tried to do in Stansted was to recapture this clarity, to recapture this romance of air travel, this amazing thing that you are able to see flights land and take off, and throughout the airport there is this clarity and legibility. So Foster's sketch that you see here shows there is a very simple passenger flow, clear orientation, linear circulation from drop off to check in and the various other steps that we take before we get into a flight. There is transparency and visibility. Passengers were able to see the airfield when they were in the concourse. The romance of the early airfields, which maintains the views, bring in lot of natural light and a sense of connection. Thus, Stansted Airport began with what came to be called as a single envelope design. An airport terminal where all the functions are enclosed under one continuous roof volume and not scattered in multiple small buildings. Now I will have a check on this single envelope design because there have been two previous designs which had a similar intent, both designed by Eero Saarinen, the Dulles Airport and the TW Terminal, which I have already discussed with you. under late modernism. Both of them were single envelope designs. Why was Norman Foster's design so different or unique, though it was carried on from the same idea? Because he revived the concept of modular high-tech construction in the Stansted Airport. So this single envelope concept has a clear span shed-like hall. Services were hidden below the floor under the concourse, though so that the upper volume remains completely open and uncluttered. It became a prototype for all the mega terminals to come and strongly made the single envelope concept popular in contemporary airport design. It reversed the hierarchy, turned the building upside down, removed all the heavy services and took them to the undercroft of the building, keeping the concourse level completely free. Thus it freed up the roof and ground plane for passengers and daylight, as you see here in this picture and other pictures that I will show you. So the concourse became a single volume and the rail link was there in the undercroft, creating a terminal that could be adapted and expanded. So this modularity, the ability potentially to expand began early from the Stansted Airport. There was also light, space and wayfinding. From the traveller's point of view, the movement through the entire complex became very straightforward and direct. There were clear sight lines. The passengers could see the aircraft, the gates, the exits very easily. There's a lot of visual openness and that reduces stress and confusion when people travel. Travellers always know where they are in the Stansted Airport, which way they are facing. They can see all the 4 glass walls. It's a very huge enclosed space. So these are the plans that you can look at again to show how the airport has been organized. None of the level changes and subsequent orientation problems, as was typical to most airports, we don't find them here. Passengers have this fluid movement through the airport. Departure lounges, they can see the planes land and take off. There is an automated transit system that takes them to the satellite buildings to board their aircraft. This picture shows how the airport was built and the roof was built first. So we see the earlier ideas of high-tech architecture being brought into it, modularity and prefabrication. There is a major cantilever at the entrance of the airport and the structural clusters form the technological aesthetic of the building, as is true for earlier high-tech buildings. The focus is on flexibility and economy. The structure is very simple. Interior open spaces have a roof supported by these lightweight steel trees. It's a system of mass and tension rods. So how is it built? Each tree has a trunk. Then it has these 4, so there are 4 massive steel columns forming the trunks, over which there are these 4 steel branches. In between them, they are braced by these tension members, which are all attached to a single bolt over this pyramidal shape on the top of the trunk. So you see this entire structural system that is supporting a grid of 36 by 36 meter bay, and the entire thing can be expanded like a kit. So the original concept of kit of parts in high-tech architecture is applicable here. The terminal that could be expanded, long span structure with column free passenger space. There are these 4 steel branches that form this square grid and that support this space frame roof, which is a very lightweight roof to keep out rain and to bring in natural light from the top. So another thing that Stansted brought in is the concept of bringing in maximum natural light into the airport building. No mechanical, electrical systems were there in the ceilings of the walls. The structural tree in fact served to provide these services for air, light and power. Each tree column worked as a vertical air shaft with 4 vertical supply ducts around the sides. Space in the middle is for the return air duct. All of it is connected to the undercroft, there is a plenum room below the concourse floor here, to which the entire services network is connected. The AC plants are also hidden below the floor level, and the fresh air comes through the tree and there is an intake of stale air also through the tree that also works as an automatic smoke vent. There is also a spiral staircase given within the tree from the underground level, where you maintenance crew can come and service the airport. So services below and space above, the high-tech concept became applicable here. Around the outside of the trunk also there are services at the floor level, and this entire system is not attached to the concrete floor, so that if there is any differential movement, they will not be affected. There are also uplighters over this tree that combine with the reflective dome at the top, and thus there is a giant light fitting here. Glare free illumination happens throughout the airport, a similar concept that he tried to do in HSBC Hong Kong with the sun scoop and the mirror. Daylight is also brought through the roof glazing between the structural trees that you find here. Daylight is also coming in directly. So this skylight design of bringing in daylight was a radical step in airport design, entirely daylit except for very overcast days, and there is also constant change in the play of light from day to day. So there is industrial precision, exposed structural, modular logic, all a part of the high-tech architectural language. It got a RIBA award in 1991 with all these features like a floating roof, clear separation of services, natural light, and flexibility of space. A very modular and open plan. In conclusion, we can say it was a pioneering single envelope terminal model which reversed the conventional hierarchy of how airports were designed. The structural system led to a lot of openness and abundant daylight. It had significant energy and economic advantages also. Running costs were half that of other parallel British terminals. It was a prototype of contemporary airport design. So that shifted global thinking on terminal design, with the planning focused on passengers first, services below ground, and a modular expansion. Later mega terminals like his own designed Chek-Lap-Kok Airport and Beijing T3 followed the similar concept. Now as airports turned into these multimodal hubs, more changes started happening and became, post Stansted, more evolutions happened. The concept of a central concourse and a pier arm layout. What is the pier arm layout? A lot of arms projecting from the airport where passengers disembark and board the aircraft. Multiple piers and arms extend from the concourse. There are these boarding gates with these spear fingers or linear spine configuration, which allows for shorter walking distances when there are, rather than having many separate terminals, and it makes the whole expansion modular. So there is a centralized baggage and security system, and there is a very clear wayfinding because there is a single flow spine for the passengers when you want to board your flight. So there is a central concourse which is common for all the common facilities, like I talked about the baggage handling, security systems, etc. is all here. Having crossed the security check when you want to board the aircraft or when you disembark, there are these arms around it. This is the Enchen Airport, and you see these arms here also. This became a common model for all contemporary airports, having this central concourse and a pier or arm layout, like we have it in the Mumbai airport by Sigmore Engine Merrill. You see these arms here. We have it in the Istanbul airport. We had it in the Chek-Lap-Kok Airport, where what was one of the first mega airports to be built with this concept, and then it was there in the Kansai Airport in 1998. It also had it before the Chek-Lap-Kok. The big thing about the Chek-Lap-Kok was a much larger concept of an airport hub. Thus this uniformity from Stansted till today, this evolution of contemporary terminal typology from this model of a single envelope design in Stansted to linear mega hub, Chek-Lap-Kok, linear spine with natural light, Barajas Airport, a giant single envelope with multiple piers in the Beijing T3, and this, as a result of this has become the common model of or the common structure of the 21st century airport. So, two or three points I will repeat. One is airports like railway stations have become multi-modal hubs. They are literally like airport cities today. Rather than having different terminals, there is more the idea of a single envelope designed concourse with several arms projecting from it, where you board or deboard the aircraft. This is the example of the Barajas Airport by Richard Rogers in Spain, the Terminal T4 2006. Designed to handle 35 million passengers a year. Madrid's bid to become Europe's dominant air hub. Now please remember that these figures are from an earlier data. Today the number of passengers flying from these airports is constantly increasing. This also is a single envelope design, and it is based on energy and cost saving and great functionality. So it was estimated earlier it will handle 50 million passengers by 2020. Of course, this must have grown further. The concept was the building is covered with a wave-like roof supported by these central trees, a concept we saw also in the Stansted Airport. The design process is focused on creating very attractive and quiet experience with this corrugated roof at the top, having this bamboo ceiling, and the columns are in pairs having a range of rainbow colors in them, and the colors help in wayfinding for the passengers and also soothe the passengers as they negotiate the airport. A similar, not using colors but method of wayfinding is also there in the Kansai Airport by Renzo Piano. This is a very simple palette of materials, a kit of part approach, ultra rapid construction program, maximizing the potential of flexibility, so much so that the modular system used again has the potential of infinite extendability, a freestanding custom made rather than a freestanding custom made composition. What is a freestanding custom made composition different from this modular approach? This is the example of a freestanding custom made composition, the TW terminal by Eero Saarinen, which does not have the potential of expandability. The sheer size of the building is assembly focused, reflects an assembly focused approach. There is an assembly focused approach here. It is a flexible system, 18 by 9 meter structural grid that can be added on, and each one is to serve multiple uses like check-in desk, security check. That means throughout the airport the same modular grid is used, and it is multiple functions are served underneath the same extendable model. Within this modular system, the roof is the defining architectural element. It floats over the building and then it is supported on the edges by these props. Now there are 3 underground levels. So if you want to see it again, there are 3 underground levels and 3 levels above. The model legibility is this straightforward linear design, just as we saw in the Stansted Airport. But here the progression of spaces for departing and arriving passengers, though similar to Stansted, is on a much larger and linear scale in 6 floors, 3 above, 3 below ground, having check-in, security, boarding and baggage. So again, like Stansted, this has a concourse and this has an underground level. Kansai also has a simple linear horizontal sequence. Now the difference between Stansted and Barajas has also to do with the scale of the airport. Barajas is a much bigger terminal in comparison. Stansted had passengers moving on only one level in a clear straight line. So you go from curb to check-in, security, departure and to the gates. In Barajas, it's a multi-level vertical layering in which departures happen on the upper levels and the lower levels are connected to the upper levels by escalators. Passengers still move sequentially through the several levels while moving forward, but it's a bigger airport. Still, the single envelope design prevails. Given this multi-level section, the strategy is to bring natural light deep into the lower levels, and that is done by something called a light-filled canyon. So the concept that began with Stansted still holds true. Natural light has to be pulled into the deeper recesses of the airport. So here Not only do these canyons that you see here bring in light deep into the airport from the top, they also separate the different sections of the airport. Rather, they indicate the different sections of the airport related to the transit from arrival point to check-in, security, passport. There are these sequential spaces that these canyons are separating in parallel sections. So, these full height spaces are also spanned by bridges where arriving and departing passengers are able to see each other, but they are segregated from each other. Also act as locators. There is a clear sense of direction and legibility, which is so important for a modern airport, which are so huge. Moving forward, this introduction of natural light and reduced dependence on artificial light. The roof has skylight openings which bring in controlled natural light throughout the upper level that you see here, which is which leads to the departure, which is the departure area, and they project over the edges to shade the facades of the building. Here also you see these graduated colors that you see in the structural elements, not only in the columns but also in the wave roof. You find different colors have been used. There is a passive environmental design, passive design strategies in spite of Madrid's very hot summers. There is a lot of transparency and views towards aircraft and towards the mountains. Again we find the Stansted concept being used here. North-south orientation helps reduce solar heat gain. Fresh air comes from these floor diffusers which are between walkways, travelators, seating zones and conveyor belts also. What do? They supply cool fresh air at the lower level of the airport. Hot stale air rises up and then that is disposed of. But in the rest of the terminal, conventional high velocity systems that supply cool air from the roof is being used. So, very systematically it has been done. The areas which passengers use maximally and they need cool air at the lower levels, there these what are called as these floor diffusers or these ventilation systems are used, and the facades are also, as I told you, protected by these very deep overhangs, and there is also an external shading device which protects the facade. Graduated columns, why are they important? They are painted in these colors from orange, yellow, etc. This color gradient helps that there are not sudden changes happening. There is a graduated change in color, and the purpose is to help in wayfinding and also to reduce the visual scale of a very large concourse and de-stress the passengers. So, it is a very novel idea used by Richard Rogers, and if you recall, this was the idea of the use of colors earlier also in the high-tech buildings designed by Rogers like the Centre Pompidou. So, natural stone flooring has been used throughout the entire terminal to bring about this seamless integrity of space. Now, there is a contrast in the way the lower levels, 3 lower levels and the 3 upper levels are designed. The lower levels of the building have robustly constructed in concrete, in contrast to very lightweight and transparent construction of the upper levels where the passenger areas are. This bamboo roof detail, heavily insulated roof which is clad with these laminated strips of Chinese bamboo, and it brings warmth. So, again and again Richard Rogers is trying to create that warmth, that feeling of a comfort level within the airport visually through the graduated colored columns, through the roof, and rather than making it a very cool industrial building, it humanizes the very vast scale of the airport. Natural colors of bamboo contrast with the colors of the graduated columns, the graduated colored columns, and there is a sustainable material with acoustic comfort. In conclusion, the entire airport transforms the mega terminal into a very human scaled experience with the use of this color and light. There is a clarity of passenger movement, there is a more simplicity in wayfinding through the airport. Light canyons etc. have been used to bring in natural light into the building. There is a graduated color coded column system to orient the passengers through a very long terminal. The landmark is the contemporary high-tech airport design balancing efficiency, legibility, and architectural warmth. These are some of the iconic airports that you can look at later. There are a couple of these that I will be talking to you about in later slides. For example, Beijing T3 and the Kansai Terminal. Thus, contemporary airports like railway stations have like railway stations become these mega hubs or multi-modal hubs, but contemporary airports have evolved into this single envelope passenger oriented daylight filled terminals with a lot of clarity of movement, very necessary for these massive airports, integrated technology, advanced engineering blended with human comfort, sense of cultural identity in many airports and sustainability become global gateways of connectivity, national ambition and civic pride. We will conclude here, and I will probably be able to look at a few more airports in a later presentation with you. Thank you.